Linear probabilistic modeling is a way to determine the likelihood of some event based on binary results. The model uses the equation y equals beta naught plus beta 1x plus epsilon, where y is the likelihood of the event happening, beta naught is the probability of something not happening, beta 1x is the probability of something happening, and epsilon is somewhat of an adjustment variable. If epsilon is not present, we call the equation the true regression line. Overall, we interpret this as the number of trues compared to the number of falses gives us our probability. This equation is especially useful in determining probability where there are two outcomes. One of the most common is true-false scenarios, but other such things can be substituted as well, so long as the possible results can only be one of the two things. If we were calculating a pass-fail rating of some computer code, we may use linear probability to understand it. In this scenario, there is no between value. The code works or it does not. The number of times it passes versus the number of times it fails can be put into the equation, and the probability of some code working based on certain inputs or modifications can be calculated. Within computer code, there may be more specific instances of binary choice and linear probability. Simple comparison codes that take one value, determine if it is matched to some specification, then run some function come up all the time in coding. In this scenario, we can use linear probability to understand how often the condition is true and help us predict the likelihood that the condition will be met in the future and our code will be run. Another common method is to run some code n number of times until some condition A happens, at which time we will break from the cycle and do something else. Having a model to predict the likelihood of choice A versus choice B, or the chances of breaking from the loop, is a regular thing we need to calculate. From knowing average runtimes to how much CPU usage to allocate, linear probabilistic modeling is a very valuable tool for computer engineers and programmers alike.